In our last video for our Statistics OER course, Unit 5 on continuous random variables, we will do a couple more applications of the normal distribution, and we will use the Art of Stat apps online. So the story here is that there are approximately 1 billion smartphone users in the world today. In the United States, the age is 13 to 55 plus of smartphone users approximately follow a normal distribution with approximate mean and standard deviation of 36.9 years and 13.9 years respectively. We are asked to find some probabilities and find percentiles. So I will be going into the Art of Stat normal distribution app under find probability. And I'm going to enter the mean of 36.9 years and the standard deviation of 13.9 years. And I will have this curve, the normal curve, labeled with the values of the mean being in the middle and 3 tick marks to the right of 3 standard deviation increments and 3 tick marks to the left of the mean for another 3 standard deviation decrements going to the left. And I will label my axis to indicate that this axis, the variable, is the age of smartphone users in the United States, and the unit of measure is years. So remember to always label your axis and let us know what these values represent. So these are age of smartphone users in years. And of course, we are talking about ages 13 and up. So it doesn't really make sense to have values in this area. But algebraically, they do create a normal distribution that extends to negative infinity. It's just that in the context of this problem, they don't apply. So I want to find the probability that a random smartphone user is between 23 and 64.7 years old. So 23 less than x less than 64.7. And again, remember to write the mathematical expression, but also then tell us how you used your technology when you show your work on a test. So I'm looking for an interval probability. The lowest value is to be 23, and the upper bound of the interval is to be 64.7. Not 647, but 64.7. So Art of Stat gives us the expression at the title of the chart, but also at the table below. And the answer is 0.8186. Remember that we want decimals unless they are asking us for percent. So 0.8186 is the answer for that. Let's also show this on our chart. It's from 23 to 64.7. Now we could use the empirical rule to roughly evaluate this. So we know that from -2 standard deviations to +2 standard deviations is 95% of the data. These are approximations, they are not exact. The technology gives us better values. So half of that will be half of 95%. So 95% divided by 2 will be from the mean to 64.7. And then we know that 68% of the data is from 1 standard deviation below the mean to 1 standard deviation above the mean. Therefore, from 23 to 36.9, we can say that will be 34%, which is half of 68%. So 47.5 and 34 are approximately 81.5. So we are confident that we correctly established a better and more accurate answer, obviously using technology, than what we would do by estimation from the empirical rule. What's the probability that a random smartphone user is at most 50.8 years old? So what's the probability the age is less than or equal to 50.8? And again, we can enter all of that in Art of Stat and then shade appropriately. But here, if they are asking us to use the empirical rule, we will say that from the mean all the way to the left, since the mean is the median, we have 50% of the data. And then from the mean to one standard deviation above the mean, we have 34% of the data. So we are expecting the answer to be about 84%. Let's see if the technology will give us that. I'm looking for at most, which is a lower tail, and 50.8 is the value that they are giving us. And that is 84.13. So 0.8413, which is again approximately what we were expecting it to be. Find the 80th percentile of this distribution. So mathematically, the expression is what is the value of the variable? So we are looking for this value such that the probability of x being at most that value will be 80%, 0.80. So for that, I will go in Art of Stat in the tab Find Percentile, Quantile. I have the same mean and standard deviation. I'm looking for the lower tail and I'm looking for 80%. And 80% is at 48.60 value of x. Remember, the variable is years of age. So this value here is 48.60. X equals 48.60 years old. This is the age of 80% of the youngest users of smartphones. So 48.60 will be somewhere here. And 80th percentile is a CDF, cumulative distribution function, cumulative density function, below that value. And to calculate the interquartile range, IQR, remember that we are looking for 25% of the data below quartile 1 and 25% of the data above quartile 3. So we want this area to be 25%, 0.25, and we want this area to be another 25%, another 0.25. So there are two ways to do that. Of course, the app will save us a lot of time. We are looking for probability of x being between Q1 and Q3 to equal 50%. So the middle 50% of the data is between the quartile 1 and quartile 3. So Art of Stat has the ability to do that. So it can actually give us a percentile and quartile if we want a two-tailed interval, and then it's asking us here for the central probability in percent, and that will be 50 if we are looking for the two quartiles. So it gives us quartile 1 to be 27.52 years of age, and quartile 3 to be 46.28 years of age. So I could say that. So quartile 1 is 27.52 years of age, and quartile 3 is 46.28 years of age. There is another way if I don't use this technology and maybe I use my calculator to do a lower tail distribution, and I want the probability in the lower tail to be 25%. That will give me the first quartile. And to find the third quartile, I want a lower tail to have probability 75%, and that will give me the third quartile. So if you remember, quartile 1 is the 25th percentile, and quartile 3 is the 75th percentile. And again, this will allow me to find the two quartiles. So they didn't ask us for that. They actually asked us for the IQR. So if they asked us what are the ages where the middle 50% of the smartphone users in the United States have ages in, then I would have said from 27.52 years old to 46.28 years old. But here they are asking me for the IQR. The IQR is quartile 3 minus quartile 1. So I'm looking to do 46.28 minus 27.52. And it will be measured in years. And the answer will be 18.76 years of age. The last question in this scenario, 40% of the users that range from 13 to 55 plus are at least what age? So at least means this much or more. So they are looking for the probability of X being greater than or equal to a particular age to be 0.40. Again, in Art of Stat, this will be an upper tail with a probability in the tail of 40%, and that value will be 40.42 years old. So the X value of the variable is 40.42 years. Hold. Our last example, we have a citrus farmer who grows mandarin oranges and finds that the diameters of mandarin oranges harvested on his farm follow a normal distribution with a mean diameter of 5.85 centimeters and a standard deviation of 0.24 centimeters. My variable is the diameter of the mandarin oranges. The mean is 5.85 and the standard deviation is 0.24. So I'm gonna be here in find probability probably. Mean equals 5.85 and standard deviation equals 0.24. Art of Stat automatically numbers the axis and sketches the curve. So here I have copied the axis and I sketched the curve with the correct tick marks. I have labeled my axis to indicate the variable, which is a diameter of mandarin oranges, and the units of measure are centimeters. And now I will answer those questions. It says the middle 45% of mandarin oranges from this farm have diameters between what lengths? So the mathematical expression is probability x1 less than or equal to x less than or equal to x2 will be 0.45, and we are talking about the middle 45%. So we are looking for two values that collectively gather 45% of our data in the middle of the distribution. And the easiest thing to do that here is to actually use technology rather than do the math to find the probabilities in the lower tail for each one of them. So actually I'm going to go under find percentile quantile. I'm looking for a two-tailed test with a central probability of 45%. and the values are 5.707 and 5.993. So 5.707 and 5.993. Remember to use units here. These are diameters of oranges, so they are measured in centimeters. And also to round correctly. If they wanted us to round to the nearest tenth of a centimeter, we will have said 5.7 centimeters to 6.0 centimeters. Find the 16th percentile and interpret it in a complete sentence. 16th percentile is actually really close to the 1 standard deviation below the mean. So they are asking us to find the value that has 16% of the values equal to or below it. So again, I will be in the find percentile quantile tab. I am looking for a lower tail. I want the probability there to be 16%, and the value is 5.611. So the mathematical expression, the probability of the variable being less than this value, 5.611, equals 16%. And we kind of knew it. It was pretty accurate. It is 5.61 was our values there. And I would say here that this is 5.611 centimeters. Then it says to use a complete sentence to interpret it. So if you are completing the notes for this chapter, I would like you to actually write a sentence that interprets the 16th percentile. Your sentence should say that 16% of the mandarin oranges harvested from this particular farm have diameters of 5.611 centimeter or less. As a reminder, the glossary in this section was, we talked about inverse functions. This is how we find the percentiles. We talked about the z-score or standard score, and we talked about the normal distribution. We did not give you the formula for the normal distribution because it is a very difficult to remember or to even use mathematically, and this is why we use technology. However, we do want to remember how to write that a variable follows the normal distribution with a mean of mu and a standard deviation of sigma.